What's up everyone? So welcome back to my channel, and this is the last problem for the short series that we have done for the last couple weeks, and we're trying to find out the following information, including the domain, relative maximum, relative minimum, absolute minimum, and the range of the given function. And to do so, we're going to use calculus, and more precisely, we're going to use derivatives to help us finding all these parts. So again, if you haven't seen the last two problems yet, you can go find out from my channel, and then you can find out the two problems as the example to lead to what we're going to do today. And also, if you have already watched those two problems, you probably know that in order to solve it, no matter what, we have to use derivatives to help us. So it is also an application of calculus, or in this case derivative, and see how we can actually use the idea of it to bring us to other kinds of problems, or even real life problems, and how we can actually apply it to give us the answers that we want. So this problem that we have as the last problem of the series, it will be a mix of the two functions that we have in the last couple of videos, which says y is equal to, again, is a function, we can call it f of x, which is defined as sine of x raised to the sine of x power. And of course, we're trying to do it with real numbers only, because I expect the viewers of this videos are at least having a like some certain level of calculus knowledge already, but I did not expect to go any beyond that. So we're not going to consider anything further than just the real numbers. So of course, you can try to pause the video at this moment and give a try, so that you can actually see if you can actually get the same result as I do. And as we can see, this time we're not just raising to x power. We don't have the base as x either. We're trying to change it to make it more complicated. So I'm going to break this video into at least 3 parts. It could be even more, because it's going to take too long to actually put everything into one video. So here we go. First, we can of course try to find all these, but since we have to use derivatives to help us finding all these informations, we're going to first take the derivative of this function for this part. Okay, so as we can see, we have this function here, and here we go. How should we do this? Well, before we take the derivative right away, we don't have a nice base here. In fact, we have an uncertain base, or a base with variables in it. So how should we do it? We're going to rewrite it into some fixed base, such as base 10 or base e or base 2, however you want. But of course, for of course, because we already know how to calculate or take the derivative with e to the some power, we're going to do it that way. So how do we write it? Well, for this part here, we're going to write it as e to the ln of, now what should we do here? Should we put absolute value or not? Of course, we are not going to put absolute value here, because we might actually have negative sine of x. So in this case, we're going to get the following. Then, of course, we still have the sine of x outside. We're going to raise it to the sine of x power. So now if we combine it together, we get e to the sine of x power, which is from here, times ln of sine of x. Like this. Good. Then now we have e to some power. We can use the chain rule to help us to find out the derivative of this. So if we take the derivative, we still have e to this thing. But if the exponent is not just x, but some other or not a constant, then we have to do the chain rule, meaning we have to take the derivative of this part. Okay, so what should we do here? Well, since we have a product, right? Now we have to use the product rule to help us getting the derivative of that, which is, by the product rule, we're going to take the derivative of the first function, which gives us cosine of x, times the second function, ln of sine of x, plus the first function times the derivative of the second function, which is, again, we have ln of something, so we get 1 over the term inside of the natural log. Are we done? No, because this is not x. We have to do a chain rule one more time. What is the derivative of the function inside? Well, we have sine here. So again, the derivative of sine is cosine. Then we can now try to simplify everything. Keep in mind, here we can just rewrite the e to the ln of sine of x as sine of x, just like what we started off. So we actually have a sine of x, raise it to the sine of x power, times. Now let's see what we can cancel out. First part, there's nothing we can do. Second part here, the sine and the sine will cancel out. So we end up with just cosine. And in this case, we have cosine here and cosine here. We can factor the cosine out, and leaving us with just ln of sine of x plus 1. Okay, so I'll pause the video here, and this is a good place to end the first part. So in the next video, in part 2, we're going to analyze the function as the original function as well as the first derivative function, so that we will actually start finding the domain, the range, as well as the relative extrema and the absolute extrema. Okay, if you enjoyed this video, don't forget to like, and if you have any thoughts, you can leave your comments below. Also, if you didn't subscribe to my channel yet, don't forget to subscribe and turn on the notification bell so that you won't miss any of my new videos either. I will see you guys in the next video.